Good morning. Today we are going to start a new chapter, you can say. We have completed basically bearing capacity and settlement of footing. And now, while determining bearing capacity, we have mentioned several assumptions, like the soil has to be homogeneous, isotropic, then water table should be at least at a depth of B. Of course, if there is a water table location varies, then we can find out, or you can incorporate the bearing capacity into it, or you can incorporate the effect of the water table in the bearing capacity. Similarly, if the instead of homogeneous, if it is layered or something else, then also can be done, but we have not discussed that. We have used only homogeneous case. Similarly, for settlement also we have shown that if you require several parameters, like you need to find out, if you want to find out immediate settlement, then you need to know Poisson's ratio, you need to know the Young's modulus of the soil, again whether the soil is homogeneous or layered. So, that information is required. Similarly, if you want to find out consolidation settlement, you need to know the whether the soil is a compressible one or not, and then similarly if it is compressible, then we need several parameters like CV, CC, void ratio, many other things to calculate the consolidation settlement. So, that means and also you know that consolidation is a phenomena for a saturated fine grained soil. So, water table location also is another important aspect. So, we have so far done those problems, we handled those problems, bearing capacity problem or settlement problem by a known situation. That means, we have given the profile, we have given the soil parameter, we have given the footing size, and based on that how to find out the bearing capacity. Okay. So, that much we have done, but we have but how to get those information, that means so what below the footing, what type of soil is there, what is its phi value, what is its C value, cohesion value, what is its Poisson ratio, Young modulus, or any other similar, how is the grain size distribution, or how is the soil type. So, those information actually how to get. So, that is the thing, to get those information we need to we carry out geotechnical investigation actually, that means geophysical exploration and or soil exploration and geotechnical investigation. So, soil exploration means up to certain depth actually you need to explore the soil type, you have to know the type of soil, and for that we do something. So, those things actually there are geotechnical investigation. Under this we will discuss those aspects. Basically what are those? Those are actually your initially you have to make borehole and then see the stratification on all those things. So, maybe 4-5 lecture or module I will spend on this to address the geotechnical investigation. Let me go to the first slide of this geotechnical investigation. You can see that geotechnical investigation you need to know what is our goal or what is our objective. Okay. So, that objective is actually the estimate geometry of soil strata and groundwater. As I have mentioned that if there is a footing here, whether the soil is homogeneous infinitely or whether it is layered, number of layer, or the soil parameter vary with some depth, all those things are those variation actually you have to show geometry of soil strata, you have to know. And then another thing is that if the water table is here, the whatever bearing capacity, and if water table here, bearing capacity will change, that actually you have shown. So, because of that this groundwater table also another important aspect, actually first thing you have to find out. So, estimate geometry of the soil strata and groundwater, this is first thing. Second thing is the field investigation. That means, what is the actually identify materials and layering, that means we have to suppose this is the layer we have got, this is a layer, suppose this within these actually soil may be homogeneous, but whether it is sand, whether it is clay, or whether it is silt or a sandy silt or sandy clay or clay silt, like that, this can be many things, or it is a gravel, sand gravel. So, like that. So, identify materials and layering. So, these two things, and retrieve sample, that means when you carry out this investigation you collect sample from different depths. So, actually if I collect a sample from here, this will be the representation of this some area actually. So, we will collect sample here, from sample from here. So, those sample to be collected for what purpose actually? To carry out test in the laboratory and to find out the engineering properties through retrieve sample for engineering properties of testing in the laboratory. And in addition to that, during this process we can also carry out some field test, by which directly we can find out the engineering properties, some engineering properties like C, phi and all. So, they are actually directly it will not give, based on experience people correlated actually with certain things, field experience, they have correlated C, phi and other parameters. So, we will discuss those things later on. So, that means what? First of all, this investigation, stratification and layering, that identify materials and layering. So, first of all geometry of soil strata and groundwater, then identify materials layering, then retrieve sample and then carry out field test to find out engineering properties. And then last part is whatever sample we collect, that sample actually ultimately laboratory testing. So, determine engineering properties from samples, that means whatever sample during investigation part we collect, those soil sample will be tested in the laboratory to find out engineering properties like C cohesion, friction angle and similar other parameters. Okay. So, let me go to the next slide. You can see that site reconnaissance. Site reconnaissance is nothing but actually one sort of survey without any instruments, only physical, you visit the site and then see the surroundings and note, make a note of it. What are those? All sites should be visited. Any proposed project actually, suppose is selected a place and then to study the suitability. So, first of all you have to visit the site, and that has to be not like ordinary person, it should be by experienced professional to collect first hand information. What is those first hand information? First of all you have to get the geology of the site, you have to know the terrain of the site, you know the equipment access, that means if the it is a forest or a hill area or something else, then you have to explore whether for a particular facility we need to move with different types of vehicles. So, whether that access is not there or whether it is there or not. Then existing structure, that means that the nearby areas, what are the different types of structures are available, that has to be seen, whether it is a tall structure or it is a small structure or it is a some other type. So, that has to be seen. Based on that actually we will get lot of information why they are not doing tall structure. Suppose if no tall structure is there, there may be some reason. So, that to be seen, and then they are the tall existing structure and their condition. Suppose there are existing structure and you may find that most of the buildings are having cracks. So, that means what are the type of building and their condition, both should be seen. And suppose as an example, as I have mentioned, that there may be a struck building, everywhere there is cracks, then what is the reason for cracks, that has to be also investigated, talking to nearby people and all. For example, suppose if there is a area with expansive soil, and if the small type of house buildings are there, then small building on expansive soil generally will have cracks, mainly because of this expansive soil, when come in contact with water, it volume increased, and when drying actually volume decrease, and because of this seasonal variation of the volume of soil, the building will generally goes up and down, and because of that mechanism sometimes buildings will have some cracks. So, those things, that existing structure should be seen and their condition also to be seen, and existing utilities and potentially hazardous condition, whether potent, like if it is a close to sea shore, then there will be some problem. If it is a somewhere else, there may be industries are there, there also may be some other problem like that. Those are the things to be noted in the beginning, that is called site reconnaissance by an experienced person, site to be visited, and these are the things to be noted. And next part is, and then further there is checklist. Actually, you can see under checklist the examine exposure of soils and rocks in carts like this. If you see the carts and carts, that means this is the excavation, and you can see it is actually hand drawn, because of that so distinct, but it may be somewhere layering may be like this, somewhere layering may be like this inclined. So, it may be there, lot of variation will be there, but if there is an excavation going on, then or if there is no excavation also, if you can make ourselves, and then you can see the distinct variation of the soil type with depth. So, that means examine exposure of soils and rocks in carts, that means highway, railways. Then building excavation, there also you can see gravel pits, then stream banks, then if the river etcetera there is a bank, there also you can see, and on the surface and note effluent groundwater seepage. If there is a cut, and again you may see that somewhere water is coming seeping. So, that is also to be noted, at what depth water is there. So, that has to be done. So, this is the checklist, that when you have to examine these are the things. Then examine slopes for sign of instability. If you see some site, there may be some natural slope, and you have to see by visually, by seeing the slope angle and material, you will be able to visualize whether the slope is stable or unstable. Then examine the existing structure and pavement for sign of distress. Okay. So, as I have mentioned that the expansive soil, on the expansive soil, if there is a road, normal road, then you may find cracks because of this seasonal variation of moisture content in the soil. The pavement will goes up and down, and that may result cracks. So, that is examine existing structure and pavement for sign of distress. So, these are the things to be noted. Note evidence of flood levels along streams. Sometimes if the river or something, if it is full, we will see, but if it is at a bottom level also, you may see that this water table sometime will goes up and down. So, there will be some mark actually up to which a maximum level water can rise, that there will be some indication in the bank itself. So, that are to be seen. So, these are the things to be noted. Next one, checklist continued. You can see some more points. Contact local well drillers for information on groundwater conditions. So, those people who are well drillers, they will be having locality wise, they know at what depth water is available, and also they know the soil type, because while drilling for in search of water, they also find difficulties, and based on that they know what level, what type of soil, or if there is any rock, and what level, there may be multiple layers of water, but which level of water is good, all those things information will be available from the well drillers. Similarly, contact local public official for building code data and information on foundation and soil condition. So, that means local officials, they finally certify the building type and then the structure and all. So, from there we can get some information on what are the different types of foundations are used in that locality, and what is the reason, all information may be available from them. Similarly, note site condition imposing constraints on access for exploration equipment. So, this is already I have mentioned that specific if you want to detail soil exploration and construction, and that time what is the constraint, that has to be also noted, and then based on that feasibility studies of the project will be done. So, next let me go to this desk study prior to field investigation. What are these? What are those actually? Air photos. This is one thing, that means vegetation, ground color, then slides, faults, all those things from the air photo. That means from the air photos, these are the information will be available. Then maps, you have to consult the maps. So, from the map what will get topographic, geologic, and from the geologic map we will get rock type on surface, deposition of soils, geology, etc. we will get from the geologic map, and topographic map means how the surface is and what are the features, etc. are there, that can be obtained from this. And nearby structure, actually you have to see that there is close to the site what are the different structures are available and all those things, that has to be noted. Literature, that means previous reports and published work, that means sometime people will carry out some investigation on failures and all. Sometimes they will be available in the literature as a case histories, and if you get this, sometime it will be helpful to take some decision. And like that, there may be some difficulties because of that, some or there may be some failure, there may be some investigation team is formed, they might have submitted report that may be available, or sometime because of this academic nature of publication, like suppose a high rise building is constructed and then it is monitored for some several years, and then some data is published in the form of case studies, then that also can be seen to get information what will be the difficulties or what is the advantage available in that particular site. Then local knowledge. Okay. So, local knowledge means sometime you have to consult local people, they sometime may have lot of information about flood, earthquake, many other things. So, that to be also considered. And then next part is so although after seeing all those things, and when the project suppose felt is feasible, then you have to get the subsoil soil exploration you have to do. That means, as I have told that is the basic requirement. You can design, you can, if you have a soil data and all, you can design a foundation without any difficulty, but how to provide the data, where from it will come, because foundation will be there and foundation will carry some load, and that load will be transferred up to a great depth, that we have seen that the how the pressure distributed over depth, and that means so you need to know that soil type up to some depth, where actually because of the foundation pressure will go. So, that actually for that actually you need to do some subsurface soil exploration, and that subsurface soil exploration will have 3 steps actually. So, this is not required. So, 3 steps will be there, one will be the boring, another will be sampling, and third one will be testing. Boring, sampling and testing. So, boring refers to drilling or advancing a hole in the ground. So, that means, if there is a ground, then you have to go deep and you have to make a borehole, and while making borehole the soil will come out and you have to observe continuously. So, suppose up to this depth one type of soil came, then from here to here, when you cross this one, suppose soil type change, and again up to reach it is constant, then maybe after reaching some depth again there is change. So, this observation will make, finally soil profile will be made. So, you have to drill a hole and or advancing hole in the ground. So, and that how what depth etc., that and what will be diameter etc., will spacing, all those things I will discuss, but generally this drill hole will be from 75 millimeter to 600 millimeter. Actually, most typically actually 3 inches to 4 inches, that means 75 to 100 is more common. Large number of boreholes will be there in the most of the sites, all will be between 75 to 100, sometimes 150 also, but common, very common is 100 millimeter. So, those boreholes will be done, that is steps in subsurface soil exploration is boring first, that we have to advance a hole deep enough. That means, what are the depth etcetera required, that I will come later on. And then sampling, while doing this, occasionally what we have to do refers to removing soil from the hole. That means, as I have mentioned, when we are advancing the hole, and that time whenever we will see there is a change of soil type, then immediately we can collect a representative sample, and that representative sample, that is called sampling. And then how to sample it, whether it is disturbed, undisturbed, how to get disturbed sample, how to get undisturbed sample, that also I will discuss later on. So, that means, while making the advancing the borehole, you have to collect the sample also for testing. So, that is second part, and third part is the testing. That means, when you get the sample from the borehole, that has to be brought into the laboratory for characterization. Characterization means what? First of all, some index properties like liquid limit, plastic limit, grain size distribution, unit weight and all those things. So, moisture, field moisture content we have to find out, and then afterwards you have to find out the strength parameters like C phi, and then you have to find out compressibility parameters like Cc, Cv and other things Mb. So, that means, so first part is boring, second part is sampling, third part is testing, and testing means determining or characteristics or properties of the soil. Then how to determine the number of boreholes. So, we have to determine, those are the things. I think this is wrongly written, but anyway, number of boreholes and borehole spacing and location. So, you have to yes, we have to determine, actually I have mentioned that previous slide, that you have to do borehole, okay, and you have to collect sample and you have to do testing, but that borehole again you have to find out how many numbers required, what is the spacing, what should be the location, what should be the depth. So, these are the things to be determined, or this has to be specified, because this borehole will be done by a contractor. You have to very clearly you have to give in the contract that you have to draw a map, and you have to mark on that map what is the location, and then you have to also mention what would be the depth, and then while finding out the location etcetera, you have to know what should be the spacing required, minimum spacing. So, based on that only we have to fix, and accordingly if there is a site, then how many numbers are required. Small site, maybe one is required. So, if it is bigger, then it will be more numbers of boreholes will be required. So, like that, number, spacing, location and depth, these are all to be determined. Then type of sampling device, then you have to fix that what sample device will be used. If you want to find out undisturbed sample, the sampling method is different. If you want to collect disturbed sample, the sampling method will be different, and different sampling sampling device are there, which can give you the undisturbed sample, that also we will discuss later on. Then sampling interval. Sampling interval means I am doing borehole like this, and then at what depth actually I will collect sample. So, there are some guidelines actually, there are I will discuss that one every some distance, or otherwise wherever there is a change in soil type we can have one. Suppose from this depth to this depth there is no change. So, there is no point of collecting several samples. Instead of that, I can collect 1 or 2 samples, or similarly if there is no change also, sometime minimum spacing interval actually it is mentioned, that accordingly you have to collect the sample. Then additional in situ test. So, while doing this borehole, and I will discuss that one later on, along with borehole one can conduct that SPT test and CPT test, all those things. And so, so if it is possible, that can be conducted, because that SPT data can be correlated with many other soil parameters, and so you can do in the laboratory, and at the same time you are getting from the field. Both results can be compared and decision can be taken for the better project, for the betterment of the analysis and design. Similarly, relationship with laboratory testing program, that means how we will do laboratory testing, that should be made, and then some instrumentation actually can be done. So, these are the things to be done. So, next thing is you can see borehole spacing. Now, whatever I have mentioned in the previous slide, borehole spacing is here mentioned. The spacing depends on project, surface condition, etc. Okay. So, you can see for a normal building and reasonably well level ground, approximately 15 meter or 50 feet apart in both directions. Suppose if this is the area. So, if I have a borehole here, if I have borehole here, approximately this will be 50 meters. So, in both directions, and similarly in this direction also 50 meters. And if this type of a small area, there must be a middle also, there may be another borehole. So, both the focus on corners and key interior location. So, normal building, this is the generally it is given in not 50 meter, it is 15 meter interval and 15 meter intervals, and same time corner location to be seen, or if there is any the building plan, you know the where actually heaviest load is likely to come. Those are the areas, critical areas to be selected as borehole location additionally. And site development, that means every site development means this is a barren land, nothing was there. Okay. So, in that case, first of all site to be level out for project. So, for that every 50 meter 50 to 150 meter apart for preliminary studies. Initially, first of all for preliminary studies one can do borehole in 50 to 150 meter apart. So, in between it can be 100 meter also, it can be 125 meter, it can be 50 meter, it can be 75 meter. So, anything in between. Similarly, borehole spacing again continued, you can see soil wall or cut. If there is a excavation like some excavation will be there. Anyway, I will not be able to draw here, leave it. So, if there is a excavation actually like this, if the elevation if it is like this excavation work, then you have to excavate suppose a canal. So, for a long distance, then or some other reason. So, you have to do borehole in every 30 meter interval. Earth dam, when you construct earth dam, and for that if you want to do the soil investigation, every 60 meter across foundation you have to find out you have to do the borehole, and in the road actually every 100 meter interval. Suppose there is a road several kilometers, so every 100 kilometer distance you have to find out the you have to make borehole to find out the soil characteristics. Similarly, for borehole depth, you can see for buildings to a depth where vertical pressure is less than 10%, as I have told that footing, when there is a footing and your vertical stress will be distributed like this. So, at some depth whatever pressure here, if it is q and here actually 0.1 q suppose. So, this depth actually how much you have to find out this depth. So, up to at least that much depth. So, generally this 10% happen at 2 to 3 b depth. So, because of that you have to investigate or you have to make the borehole at least this much depth 2 to 3 b. If the b is 3 meter, then it will 3 into 3 9 meter depth, up to 9 meter depth you have to do the borehole, and in no case it should be less than 10 meter. So, it came calculation 9 meter, but you have to go up to 10 meter, and if it is rock then minimum is 3 meter to be done. If soil strata exists, that means while doing this if you find there is a continuously very soft soil layer, then you have to go some deeper to find out up to which that is existing, because sometimes that will contribute lot of consolidation settlement. So, for that reason you have to go deeper and up. Similarly, borehole depth again for cut, the depth should be 3 to 4 to 1 times of the base width. If there is a cut something like that, base width is b, then your 3/4 b to b, that should be the depth of the borehole from here. Then if it is excavation 2H or 2B, this is also excavation similar. So, it is 2H or 2B. Then earth dams half times the base width, and then if it is a pile 3 to 5 meter below the pile tip. That means, if there is a pile foundation, we have not discussed yet, this is a pile foundation suppose, and then from pile tip it should be 3 to 5 meters. So, this distance should be 3 to 5 meters. So, that means, you have to do borehole up to this much depth. And sampling interval, you can see that every stratum or every 1 to 3 meters. So, suppose if there is a borehole we are doing, and there may be stratum we are getting like this. So, either every stratum, that is minimum, or 1 to 3 meters. So, generally in SPT, when we carry out SPT test, then we carry out every 5 feet interval, that means 1.5 meter interval we collect the sample. So, that is one thing, typically every 1.5 meter. Okay. And boring and sampling, that is actually you can see field engineer should record all relevant information. That means what, actually boring and sampling program when it will take, then first of all you have some sheet, and on that sheet, top of the sheet, you have to keep these are the information: time, what time you are carrying out test, what is the date that has to be taken, weather, winter or summer or rainy season, type of equipment we are using, different types of boring equipment is there, I will discuss that. Casing used, whether uncased or cased, the when you do borehole, some soil you have to use casing, otherwise the side will collapse. The drilling mud or dry, depth at which water table first encountered, that has to be noted. Loss of drilling fluid, if it is happening, that has to be noted. Water table at the end of the boring, what is the final water table, that has to be, and anything unusual. That means, while doing this borehole, sometime you may encounter some sort of difficulties, how you have handled, and from that you will get that whether there is rock layer or steep layer, all those things information. So, in the top of the boring program, you have to write these are the information for clarity. With this, I will stop here. Thank you. I will go to the next one.